Hi there everyone, welcome to the video lecture series on set theory. Let us continue our discussion in writing proofs of some statements of set theory. Here I take up the following statement, that is, we have to prove that A minus B union B minus A is same as A union B minus A intersection B. Now, in our previous video lectures, we had done a very rigorous style of proving. For proving this statement, I shall use an approach of definition and laws of set theory, which becomes more handy and easier for most of the people to write and develop the skill of proving the statements. So let us take up that easy version of proving the statement. So consider the LHS, that is A minus B union B minus A. Now by definition of A minus B, we know that A minus B is same as A intersection B complement, right? So consider this as A and B as two different sets right now. So if I say the similarly B minus A on that same line will become B intersection A complement. Okay, so when I do this way, I can write, this is because of the definition, so I write here that A intersection B complement for A minus B union B minus A can be written here as B intersection A complement. This is by definition. Now recall, we have to do distributivity. For doing distributivity, observe here carefully how here I'm doing this. See here, I can see there is this union sign, right? And there is this set B intersection A complement. I have to distribute this set with the union over the intersection of two sets. So how am I going to do is that with A, the entire set will come along with the union, okay, and this intersection sign over here that you see shall become the operator between the two sets when you distribute. Okay, so and with B complement, this again the entire set will come. So you can see with A union B intersection A complement has come, right, and the intersection sign has been preserved, and when again with B complement, the entire set comes with the union. Okay, right, so this is because of the distributivity. Now we have taken the right side of the element into the bracket, right? We have taken the right element into the bracket, that is B intersection A complement. That's why this is basically the right hand distributivity, but it's okay, you can keep it in your mind. It is distributivity. To be more specific, this is right hand distributivity. Okay, now let us see how we go further. Now here you have that A union B intersection A complement is there. So again, when you are going to distribute, you are going to go from A union B intersection A complement. So again, same way, A union B intersection will come at the this intersection now shall come here, okay, and it will now become A union A complement. This is the main intersection sign which is here too. Okay, now for the brackets, you can see B complement union B has become B union B, right? Over here you can have that, and this intersection sign comes here, and it becomes B complement intersection B complement union A complement. So again, this is the distributivity property allowing you to do. Now what happens with A union B? You can't do anything much right now, but let us focus over A union A complement. If I draw the diagram for A union A complement, what happens is, here if I draw a diagram, if this is my universal set, let's say X, and this is A, then this is A complement, and if I do the union of the two, I'm again going to get my entire universal set back. So I'm going to get A union B intersection X, where I call this X as the universal set. Okay, now again similarly, B complement union B is again our universal set, intersection B complement union A complement. So this is because of the complement laws. Okay, so how do we proceed further? Recall that everything is inside the universal set, so whenever you intersect any set with the universal set, you will get the same set back. So A union B intersection the universal set X is again going to be A union B, so there is not a big problem. So this intersection sign comes as it is, and when I do the intersection of B complement union A complement with the set X, that is the universal set, I'll get my set B complement union A complement. Now recall over here, this is very important. Over here this is has come because of the absorption law, and recall here that we need De Morgan's law over here. So we are going to get A union B intersection A intersection B complement, right? Because B complement union A complement is nothing but A intersection B complement. That's the De Morgan law. Okay, now observe the definition of A minus B. A minus B says A minus B is same as A intersection B. Over here we have the definition, right? So when we see this definition, you can recall that it is saying whenever you have focus on the RHS of this definition, it is saying the set intersection with the complement of the another set. So this is some set A union B intersecting with some another set A intersection B and its complement, right? It's taking the complement over there. So that means it is A minus B in the by the definition. So what it means is, says A first set intersection second set complement is same as first minus second, right? So here it means A union B minus A intersection B. That's the, by the definition you got this. This is using the definition in the backward direction. So yeah, so the proof is over here. What is very crucial in this entire proof according to me is using this definition carefully and using the distributivity very carefully, because many times many students make mistake, just they replace unions by complement and complements by unions and intersections, and a lot of mistakes pile up further and they do not land up upon the RHS. Okay, so while doing the question, I request you to be very careful and alert while using the property. Observe the sets, which set is being shifted on which side along with which operator. Okay, what relation is happening between the sets, and accordingly use the law that is required. Again, recall over here, when you use De Morgan's law, be very careful and write down the notation very clearly. Okay, so this is about the proof. It's a very small proof but yet crucial in order for developing our understanding in writing the proof. Okay, so if you have understood the concept of this proof, I request you to hit like button, and for more such videos please subscribe to my channel. Till then, thank you. Keep solving good amount of mathematics.